Thank you for joining in. We'll be starting the webinar in approximately 1 minute. Good morning and welcome to the webinar today. I want to really quick let you know that after the webinar you'll be receiving a link that will include the full recording, but let's go ahead and get started. We've been fortunate to assemble a panelist of growers and experts across the Western agricultural spectrum, and they're going to discuss irrigation issues, how they've addressed them, and how to improve farming practices, including how they've used technology and analytics to better inform irrigation decisions. What we're going to cover today, we'll start off with introductions of our panelists. We're going to talk for a minute or two about what informed irrigation is, a little bit about informed irrigation in action. You'll hear from each of our panelists and how they are using technology to inform their research, help with industry practices and or grower practices, and then we'll take questions from the audience and try to address those as we go. We may not be able to answer all of your questions, but we'll do our best. First, some housekeeping. Be sure to ask questions. If you look at the control panel, you should see a question mark in the upper right-hand corner and of your attendee control panel. Go ahead and click that and send the questions over, and we will address those as we go through the webinar. So I'd like to start off by introducing our panelists this morning. We've got some great individuals who I think you'll enjoy hearing from. First, we have Greg Van Dyke. Greg is a fifth-generation California rice farmer, and he's the president of Kanpeki Rice, which is based in Pleasant Grove, California. Chandler Bennett is the production manager at Madison Farms, and he oversees berry ranches in the Central Valley. He's also the founder of Parabug, which leverages technology and drones for pest management. We also have Donohue on the webinar today. He's the innovation lead at the Western Growers Association. He constantly interacts with growers across California about technology and how to improve operational issues, and I think Dennis will bring a nice view from an industry level perspective. We're also grateful to have Dr. Gurreet Brar. He's a professor at Fresno State in the horticultural division, and he is currently conducting some cutting edge research to in essence redesign the almond plant. So we'll hear from Dr. Brar today. My name is Leif Chastaine. I am the co-founder of WaterBit. I'm the COO, and I'm involved with various aspects of our solution, our technology, and I spend quite a bit of my time working with growers to try to match what we're doing to the real needs that growers have. So let's get started. So what is informed irrigation? What do we mean by informed irrigation? That's a little bit of the backdrop for our panel today. Informed irrigation is a technique, in essence, that allows you to make better decisions, to eliminate the guesswork. It's taking and combining in-field technology with the Internet of Things, matching that with grower know-how to enables growers to make better decisions with regard to irrigating their crops. There are a number of tools that can help with informed irrigation. There's soil sensors, which most people are familiar with, pressure sensors and flow meters that allow you to monitor irrigation events and then do more advanced things like detect leaks. There's also weather stations, temperature sensors, and IR sensors to monitor the crop health and to also perform ET calculations. And then, of course, there's the networking side of things, basically getting the data out of the field, getting it into a format that the grower can use, and transmitting that in a real-time basis so that the information is available readily to the grower. But in essence, the idea behind informed irrigation is to augment what the grower already knows, what their pre-existing knowledge is, with actual information in real time to enable them to make better decisions and really seriously eliminate the guesswork. The benefits of doing it are extensive. From an operational perspective, it runs the gamut from just simply putting the right water at the right place on the right time with the crops, which can help with your disease pressures. It can help with your water use efficiency. From a financial perspective, irrigation is one of the biggest inputs to crop quality and yield, and making better decisions and more refined irrigation systems help with the finances. From an environmental perspective, there are potential benefits as well, including things like nitrate leaching, which is a giant issue in California and elsewhere across the U.S. Really, it's kind of the core, if you will, to sustainable operations. Before we jump to our panelists, I want to talk really quickly about what WaterBit is doing, and we'll try to keep this very brief. In essence, WaterBit, what we have done is we've built an automated irrigation system, and it all starts with this little white box that you can see in the picture here called Carbon. This is our field node. It's what talks to sensors and actuators in the field. It's solar powered. It has a small solar power on the top, and it's a device about the size of a box that can fit in your hand. That device collects information in the field from soil probes, from flow meters and pressure sensors, and then it communicates it to the cloud using a long-range radio protocol. This communication is done up to about 1.5 miles, depending on the crop. Once we've got the information at the cloud, then we can take action on that information by controlling the block valve controller. The block valve controller in this case is a wireless primary valve that allows you to turn valves on and off in the field. And then finally, all of the information and control is sent to the cloud, where a grower can interact with the information, they can analyze the information, they can review irrigation schedules, look at events, and then upload actions that the system can then monitor and operate in the future. The idea behind all of this, of course, is to provide a grower with real-time information that they can then take action on, and then to monitor what happens, and ultimately to drive results through the reliability of good decision making. The results that we're seeing in our implementations are significant. I'm going to talk about this from two different perspectives. First, from a grower's perspective, one of our customers is a company called Devine Organics. They're an organic grower in California. They deployed a implementation of our system across a couple of fields of asparagus, and they were able to both reduce their water use over the course of the season by 6%, and increase the yields that they harvested out of that asparagus field. They nearly doubled it. It was about a 45% increase in the yields out of that field, largely due to the ability to irrigate when the field needed it, and not have to physically visit the field to turn that on. And these types of results are similar to what we're seeing, perhaps not the yield amounts, but certainly water savings and then increased yields across our customer base. I also want to talk about Clody-Le-Tech. We're fortunate as a company to have involved with the company as an investor and as the chairman of our board, a gentleman named TJ Rogers. He has a commercial winery, Coletta Tech, and he each year runs autonomous irrigation and automated irrigation experiments in his winery. And we use that information to understand both the technology aspects and try to improve the capability of our technology, as well as to understand what the impact and the result of different irrigation schemes are, as well as being able to correlate the data that we're seeing out of that field to other well-known approaches, ET, leaf water potential, etc. Last year in the experiments, TJ was able to maintain the total yields in the field and the total quality, but he was also able to reduce his water use by more than 38%, tremendous water reduction, and that was by irrigating using a pulse approach, putting very small doses of water on his vineyard at more frequent intervals. The other thing we were able to identify was that the subsurface drip in the soil type that he has was putting water down below the root zone, and much of the water was being wasted. So it's a wonderful place for us to learn, and hopefully in the future we'll be publishing some of that data so that you can learn from that as well. With that, I would like to hand this off to our panelists. I'd like to start with Greg Van Dyke. Greg?
Yes, thank you, Leif. I guess I should talk a little bit about rice and how we do it a little bit different, and how the application of this technology is specific but can be applied dramatically in a couple different ways in rice. Typically in California, we grow rice in a fully flooded environment. We do our field cultivation, then flood the fields, and then we fly on pre-soaked germinated seed, and then we keep the plant in a completely flooded environment until about a month before we're ready to harvest, and we pull that water for dry down so we can get our equipment in. My family developed a way of growing rice in California that's dry seeded, where we do all the same type of cultivation leading up to our plant bed, but then we put on dry seed in micro furrows and then compress the seed with a flat roller. And then we do a pre-emergent herbicide rather than post-emergent herbicides like in most of rice. And then do a series of flushes throughout the growing season to a certain leaf stage, and then we bring on a permanent flood. So in application of what we've been doing in developing this way of growing rice is really the cultural knowledge and historical practice of understanding how dry we can get the soil, how much we can stress the plant before we bring on subsequent flushes, as well as trying to pinpoint the certain dry down effect that we use to try and kill some invasive aquatic species that aren't as hardy to that in rice. So the way we've implemented the technology is we've taken 80 acres out of our production, and we've applied 3 sensors throughout, 3 carbon node sensors with 1 communication station. And what we've been seeing is being able now, through the data on the backside, we can not only see what the rice plant has been using, we can correlate our soil temperature and our outside air temperature with what the actual dry down curve is in between flushes. And we can also pinpoint specific soil moisture and temperature and correlation to where we start seeing dry down effect on certain plants. So in our dry seeding way of growing rice, we're able to reduce water consumption over a flooded environment by about 15 to 20%. We've never been able to totally calculate that until now we've had the WaterBit technology. Part of this is we're trying to grow rice in the most sustainable fashion and then implement that in other places around the world. We're very interested in what our actual carbon footprint is, and the data associated with cultural and production aspects of rice has never really truly been quantified by using actual real-time data. This allows me to now correlate actual data with the practices that we've been using for decades to now finally get some numbers on the page and start to quantify and get some historical data collection so that now we can apply these to our cultural practices and really pinpoint what we're doing, as well as quantify the reduction in carbon footprint that we have associated with everything that we're doing in the field. A secondary benefit to the WaterBit for us has been we're working on automation and tying in with actual flow meters so that we can even get more dramatically accurate with reducing the amount of trips into the field, like was talked about in the organic operation. That's a huge labor and also carbon footprint time savings for us. The other thing we're using the data for is we're keeping the sensors in the field throughout our decomposition time, which is in the fall, which for us, our methane output, water temperature, soil temperature, correlated to other environmental aspects, starts to paint a picture of a lot of the decomposition and biomass issues that we need to deal with post-harvest, since we have limited burning of agricultural refuse in California. This technology has been great in the way that it allows me to use it in terms of my practice of reducing herbicide use and using my pre-emergent and using then dry downs of soil with trying to eliminate other invasive weed species, so not having to re-enter the field and use the very limited toolbox of herbicides that we have in California rice. So we've seen dramatic correlations in the data now with what we know historically. We've just got done with our growing season, and I'm really excited now to apply this data and make some changes for next year and expand the application of the technology to some more acres and possibly some different varieties of rice as well. Leif, is you want me to keep going?
No, thank you. That's a fantastic introduction. I'm just trying to unmute it. Just was advancing the slide here to a picture of the technology installed in your field there.
Yeah, the other thing I'd like to mention that I forgot is how little of invasiveness there is in the field. The sensors for us, we don't have to disturb them with any of our tractors that we use. We harvested literally up to a couple inches around them. We never had to pull the technology, and I think that's important for me because I've seen the consistency and the fluidity in the data, and I would hate to break that and disturb that. But really, the carbon nodes are very small, and they can be left in the field and really don't interfere with my farming practices, which is quite a selling point for me being a farmer.
Excellent. Thank you, Greg, very much. Next up, we've got Chandler Bennett. Chandler, I've got two slides. If you do me a favor and prompt me when you would like me to switch from one slide to the next.
Sure, absolutely. Thanks, Leif. As Leif had mentioned, I'm Chandler Bennett, and I work for Madison Farms as a production manager, managing strawberries. And we've also implemented WaterBit. WaterBit's helped us solve quite a few problems and also helped us collect quite a bit of data. We've used, on the next slide here, Leif will show you some of the things we've used before from all the things tended to be a little bit intrusive, whether it be having to go out to the field and collect the data manually to just being in the way of our equipment. As you can see there's a picture of a bug back, and that's something that we use quite extensively in strawberries for pest management. And we run that tractor about once to twice a day through the field. So having something out of the way is critical. With other things, we'd have issues with bug vac or other cultural practices breaking the sensors or basically just breaking stuff. Also having the WaterBit send the data to the cloud and being able to access it via whether I'm in my truck by phone or in the office, having access to that data in real time has been not having to collect data and then interpret it and then finally make a decision. It's all right there in the palm of my hand, and I can make a decision there on the spot and send labor where it's needed. The other issue that we are having to deal with is salt management. Overall relates to fertility management, and how WaterBit helps me with that is seeing what our what's in our soil profile, water-wise and salt-wise. Seeing how the water is moving through the soil profile, allowing me to keep the moisture up, because strawberries they require constant water to keep the firmness of the berry. But at the same time, we don't want to be over irrigating, as that creates not only environmental damage but also wasting our fertilizer. So finding that perfect balance is critical for strawberries. And with WaterBit, it's helped us because, again, it's real time. I can see where the water is in the soil profile and essentially do pulse irrigation more effectively. Another thing too, although I haven't tried it out yet, WaterBit would allow me to do automated irrigation, which would allow me to turn on valves without even having an irrigator go out there, which would save me time having to send our irrigator out there. Also allowed me to run any time of the day, which would allow me to take advantage of time of use pumping, which is a benefit that PG&E would provide us if we pump during or use energy during times of low demand. They can give us anywhere between 10 to 20% in savings if we're to do that. Overall, WaterBit has helped me better manage our water and soil profile overall, which also affects my fertility management and better utilize my labor. Another thing too that WaterBit allows me to do is help me comply with regulations such as from the Water Board for nitrate, and it's still in its infancy, but Sigma. I think Dennis will be talking more about Sigma and also Water Board, I believe. But again, having all this data sent to the cloud, I'd be able to have a record of how I was managing my water, how I was managing my salts, etc. So that's some of the things that WaterBit's helped me and manage our water.
Excellent, thank you. So next up we have Dr. Brar. Dr. Brar, go ahead.
Hi, yes. All right, so let me give you my brief introduction. I work at California State University, Department of Plant Science. My specialization is horticulture sciences, plant physiology. I work in orchard systems in California, particularly in nut crops. And I have some research trials on campus working in almond production systems and pistachios. So for today's topic, actually, I would shed some light on what kind of work I'm doing in terms of almonds and what does it mean to have informed irrigation decisions for the growers. Everybody knows that we have a water problem, not just California. I was in Florida before, and I know that Florida, of all the places too, have the problem of both water delivery, water quantity, and water quality issues, especially the groundwater leaching. So all those things. When I first interviewed for a position in California 5 years ago, I was aware that California does not have enough water. So I was coming into from that angle. But over the next 5 years, I realized that most of the growers are, in fact, many of them are irrigating more. And for the almonds, it's not about saving water or the productivity, but also about the tree health. So from that perspective, informed irrigation is a must. I'm just looking at my computer screen, and I have this historical chart, a figure graph from 1982 that shows that how the evapotranspiration ET is a function of the canopy light interception in almonds. So it's a linear relationship. So as the tree size and shape grows in the conventional orchard system, we have the evapotranspiration ET demands increasing proportionally. Now, for several reasons, more reasons than one, we are trying to shift to some improved, advanced production systems for almonds. So we're trying some high density systems. So I have installed these soil moisture sensors on my campus high density planting and rootstock trials. So what I'm doing here in the rootstock trial, that I have 3 different kinds of rootstocks. I have a total of 7 rootstocks. 2 are dwarfing rootstocks, growth controlling. 2 rootstocks are conventional peach-based rootstocks, and 3 of those rootstocks are high vigor peach almond hybrid rootstocks. Now we know, just looking at the vigor, that all of those rootstocks will have different water usage, and also they would have different water use efficiency, because they will produce different amounts of crop per drops of water they use. So my idea behind putting the soil sensors was that so I could monitor the water use of those trees. Those trees are just 2 years old, so we will go into production and look at how they produce crop in terms of how much water they consume. Now, that is from a research point of view. From a grower's point of view, I always tell my growers that they have so many different options, not really options, but different methods of irrigation scheduling and monitoring. For scheduling, we use ET-based methods, we use soil-based methods, and we also use plant-based methods. Now, each one of these methods have their own value. You cannot totally substitute one for another. So the soil-based methods that we were talking about, that gives you real-time information from the root zone. That's very important. Now, coupled with that, you have the EC-based formulas that you can calculate your total water demand, and then you can do the plant-based measurements to see when you're going to turn your irrigation valves on. So all these methods work with each other, play into each other to give you the best information that you can have. One of my observations from the field has been that, particularly in case of almond trees and also other prunus trees like peaches and nectarines, that the trees could get away with less watering, but if you water more than the trees need, the trees are very quick to respond in a negative sense. So that is the plant health issue. Now, if you're doing that, if you're overwatering, you're wasting water, you're running into plant health issues, and you're not doing yourself a favor. So that's where the informed irrigation decisions come into play from my perspective in the orchard systems. Now, talking about the new improved orchard systems, when we design the new systems in the high density fashion, we are trying to grow unheaded, never headed, long, pyramid shaped, Christmas tree shaped almond trees. And in doing so, we are trying to harvest light much more in a much more better way, so that we can actually harvest more light and produce more crop for less water demand and less water use. So that's where my research is headed, and that's all I had to say for now. I will take any questions if you have.
Excellent, thank you. It's I think that it's good to hear about the fact that from an academic perspective, we're trying to address water not only from a technology perspective, but literally from agronomic practices perspective. And I think these things dovetail together nicely. Next up, we've got Dennis Donohue with Western Growers Association, and hopefully the fact that he spends his time talking to lots and lots of growers, he can provide a slightly different perspective.
Good morning, and thanks for letting me join you. And my compliments on the phrase informed irrigation, because I think that really hits the nail right on the head. And let me also add, as part of my background, I was a grower shipper for a number of years, and then I'm also the former mayor of Salinas, and I bring that up because I have some perspective on regulation and the fact that really information is going to be king for the foreseeable future, because technology per se is not going to create more water. So the ability to manage information is going to be a critical component when looking at, I think Chandler alluded to the regulatory environment. The Sustainable Groundwater Management Act is considered by many, and this is meant to just simply be a declarative statement, one of the more burdensome acts that's come along in many years, and in large part that is due to because it's meant to be implemented locally, and it's also meant to address the concerns of multiple stakeholders, and there's also a social equity component built into that. So when you think about that, you're broadening the base beyond individual operations to local communities. And then the other thing I would point out that's kind of subtle, but if you really look at California, a lot of farming operations extend beyond one particular production area. So for instance, in our valley, in the Salinas Valley, many folks are operating, for instance, in Huron at the moment, heading down to the desert, that type of thing. So you've got multiple looks at water, multiple agencies, multiple local communities. So that ability to gather information from compliance is really, really critical. And then also there's been some new additional regulation tied into the Irrigation Lands Regulatory Program. So from a grower-shipper standpoint, there's a pickup in activity. And then the other thing that I think is important to note, a lot of times when you're dealing with regulatory compliance, the grower-shipper, the processor may often be the point person in terms of gathering and providing that information. The Sustainable Groundwater Management Act, I think in many respects, puts all growers in play. So you're also expanding the base of folks that need to comply. And then the labor issue is impacting even irrigation. There's a lot of focus in terms of dealing with technology these days on field harvest, thinning, and weeding, but irrigation is also a critical component that can be impacted by some of the labor challenges the industry is facing. So those things really just really reinforce the importance of gathering information. And just going back to that idea that information or technology is not going to create more supply per se, even if you had a change in a commitment to new infrastructure, when you look at all of the elements that are involved in permits, time to construction, funding, that sort of thing, that really just very, very strongly suggests for at least the next decade, barring, I mean, we probably all like to knock on wood a little bit and hope for wetter winters resuming, but we can't count on that. So with that in mind, information really becomes absolutely critical in terms of managing water, government compliance. And then lastly, you know, we clearly live in an era where people are expecting fewer inputs. So we know we have to do more with less, and that really does tie in very directly to quality and yield. And so gathering information in a timely fashion so you can pinpoint when you're delivering water to the field or to the crop is absolutely critical to, frankly, maintaining yields is not going to be the objective. The objective is going to be increased yields despite having to essentially look to get more with less. So those would be my thoughts, and I would just close with what I started. I think your phrase "informed irrigation" is a great way to approach how folks have got to be looking at water issues for the foreseeable future.
Excellent, thank you, Dennis. I hear from growers all the time that the idea that lack of resources or availability of water and potentially not having water available is kind of the new normal, and it's an important point that I'm sure is informing the decisions that growers across the valley, and it's obviously different as you move through different parts of California and obviously different parts of the United States as a whole. But yeah, I think that is a great motivating factor. Why don't we go ahead and dive into some questions. One, I'd like to encourage, if you are if you have a question, please send them over and we'll try to address your questions. But I'm going to go ahead and kick it off if that's okay, and I'd like to get started by directing a question to Greg and Chandler. Precision data is in and of itself, and not necessarily all that value, right? It needs to inform some sort of a decision. And Greg, I know that in previous conversations with you, there's a lot of decisions that you make early in the season with regard to the temperature of the ground, and the timing of things really matters in the growing process or the methodology that you're following. So the question that I have is how does information affect your growing methodologies? And Greg, if you could start, and then Chandler, if you could follow up, that would be great.
Well, I think, Leif, you hit the nail on the head. For me and rice, we basically have about 5 extremely critical points during the year, if you will, where knowing the data that backs up then historically, anecdotally, what we know from experience, being able to now collect data at those major critical timing points for us, it really is simple, but at the same time, the data provides a hugely powerful reinforcement of our cultural practice and then the knowledge moving forward. And let me give you an example, a very simple one. We plant one crop a year, and we basically have to pinpoint with as much efficiency as we can the timing of pulling our water out of our fields to prepare for harvest, that soil dry down that not only ripens the crop, but it also allows for us to get our harvesters, our combines, our equipment in the field. If we don't get that correct, and you have to make that decision a month and a half before you're going in the field, now if we have representative data that I know correlated outside weather versus what our soil dries down, I can apply that now and actually use some science outside of just my eye to be able over time now to pinpoint that, and pinpointing that, then it basically ratchets through the chain. And if I can pinpoint that and get more efficient with that, then I get more consistency in rightness and more consistency in soil moisture, which is more consistency in plant moisture, which is more consistency in my grain moisture. Things like that are insanely powerful for me to finally be able to have the data to then fine tune the cultural practices that we've been working on for 100 years. And just having the data for us, we're the only ones in rice around the world that are using this type of technology in this way. So learning the tremendous power of it and the application, in that hindsight is 2020, is it's just insanely powerful.
Thanks, Greg. Chandler, thoughts?
Yeah, so again, having that real-time data in my hand wherever I am really gives me the flexibility to better manage not only the water in the soil profile, but also my labor, how I schedule irrigations. A thing I forgot to mention was we also share our wells with other farmers since we rotate. So a vegetable guy might need to put out some water, but being able to know that my crop is taken care of, and I can skip it, for a few hours to share the well, that adds a peace of mind. And again, managing fertilizers too, saying that I'm not pushing fertilizers below where my plants can't take advantage of it. Just overall, having that real-time data wherever I am just allows so much flexibility and a way of managing my crop.
Excellent, thanks, Chandler. We've got to have a question from an audience question here that I'd like to address real quick. And the question is, what kind of data do you get from the moisture sensor, wet, dry, and or an accurate percentage? I'm going to let Dr. Brar, you've been working with the sensors. I would love your academic perspective on what you get from the soil moisture sensors.
Okay. All right. So yeah, we just installed these sensors this season, and right now we are actually downloading the data on the water use as a percentage of soil moisture in different soil profile, different layers, like all the way from 4 inches to, I believe, 42 inches down in the soil profile. And that's what we're tracking right now and comparing these in all different treatments in our rootstock trial. So that's what I'm tracking from the soil moisture sensor.
Yeah, and I think it really depends on the soil moisture sensor type. There are a number of different probes, capacitive soil moisture probe being one of the more common probes, and capacitive probes measure a couple of different things. Depending on the vendor, they'll measure something called scale frequency, which if you ask the vendor what the scale frequency is calibrated to, they'll kind of look at you sideways, where it's basically 100% is pure water and 0% is in air, and what you see in the soil is something in between. There's a company called Syntec, and they actually have a calibration based on the soil to try to provide volumetric water content as the output. So it really depends on the sensor type and then how you're using it, and happy to talk about that further. I wanted real quick to talk about regulation, and I think that I'll just put this out for anybody in the panel, and I think Dennis, you talked about this a little bit, but over the next 5 years or so, how do you see changes in the regulation or regulatory scheme affecting grower practices, and then to what extent do you see technology being able to help deal with those regulatory changes?
Well, I think the sort of technology that WaterBit's bringing to market is the type of technology that growers are going to have to increasingly rely on. My personal observation would be the pickup in the Irrigated Lands Program and the implementation of the Sustainable Groundwater Management Act is going to be a pretty full plate for everybody to absorb, and including the state and the regional water boards and the irrigation districts. So, and even though we're near the point where everybody has to comply, the fact is everybody's not quite ready to go. So I think those will be the two dominant issues in the near term. And I think the general point I would make, the use of technology, data analytics, and the sorts of things that you're talking about today are going to be increasingly critical, because the other thing that is there is a correlation between water and inputs, and when you have rising costs on that side as well, and how much water, the timing of the water, how you manage your crop, I think that's going to be an additional focus. But I think the big thing about regulation is I think from an industry perspective, they've been coming fast and furious. We may have a little bit of a lull, but this is a big piece for everybody to kind of absorb and get on top of. So I think those will probably be maybe, and I'll defer to the growers who are still active if they would agree with that or not. But my big point is, I think everybody really needs to recognize that there's no cavalry coming anytime soon in the form of infrastructure. So information becomes really the critical element, in my view, for the foreseeable future.
If I could jump in here, this is Greg. I agree 100%. California Rice has kind of been leading the charge in terms of agricultural production groups in California over the past 30 years in implementing and working with the state and the Department of Water Resources and everything from irrigated lands to, hopefully now as an industry, we've been working to get Sites Reservoir built up in Colusa County. So hopefully our industry can continue to help lead the charge, if you will, in interfacing some of the environmental regulation mindset and delivery issues that we have in trying to create some surface water in this state that makes sense for production ag use. So on my soapbox, I would also like to say that we live in a data-driven society, and we as production agriculturalists in California, we're on the forefront of the scientific spectrum every day of the week. And if you want to survive, let alone thrive in California, being in production ag, you have to learn to adapt, and you also have to learn how to maximize the tools that are in your toolbox to not only defend the practices that that you're doing by applying real science to maximize efficiency, because as growers, that's what we're all trying to get. And the fact that we have the technology now to measure and learn things about plant physiology and how it interacts with the environment, and how our cultural practices as farmers interact with the environment, to not implement those types of technologies is insane in the type of environment that we live in, not only from the cost that this regulation brings and the cost of inputs and the maximization and efficiency of using those inputs, but also from defending practices in California that I would argue that our production agriculturists are the first and will be the last true environmentalists in the state. And being able to learn how our practices affect and interact with the environment is so wholly important that we can't ignore. And I am so proud of WaterBit and other companies like it, and the researchers in this state trying to get that information, because regulation is the single most difficult thing that we have to deal with in California and the United States, comparable to the rest of the production regions around the world.
Well,
that's
if I could,
yeah, that's enough of my
I was just going to
soapbox.
jump back in and say, and you mentioned the United States. I was a designated hitter for A.G. Kawamura for a meeting that the General Accounting Office had in Washington, and so the federal, we talk about California, the federal government's potentially a wild card also, because it may, I think your audience may find it interesting to note that as they evaluated water scarcity, and their straw man was that we ought to be focused on irrigation specifically, because that represents 70% of water, agriculture, water consumption. So, the feds could even be a wild card on this, but and then to Greg's point, with data, you do, because I think I certainly go to the same school that Greg does in terms of stewardship, and data allows us to, I think, really establish a very positive narrative that being good stewards, doing more with less, but for some reason we don't always seem to be able to kind of break through the clouds, so to speak, and make that as clear as we'd like to, that there's an awfully good story to tell. So the more data you have, I think you've got a chance to control the narrative a heck of a lot better as well.
Yeah, I think that's a good point. Real quick, I wanted to just comment that we are getting a bunch of questions, and if we don't specifically address or answer the question that you put up, we are going to respond. We will just do so directly with you after the webinar. But we do have I do have one question that came in, Greg. I think it's specifically a rice question with regard to planning for harvest. And with the right crop, the soil moisture is muddy and can create problems for harvesting machinery. Can the solution provide data to assist with harvest planning?
Yes, absolutely. As I gave the oversimplified example earlier in my answer, being able to correlate the data with the timing related to soil moisture for our big combines and equipment, it costs us twice as much to harvest in the mud, can reduce quality and a lot of other things, and takes twice as long. So yes, absolutely. We've got now 18 months or so, no, 12 months or so worth of data, and I'm in the same boat as the good doctor at the university. I'm running my models and correlating those, but any farmer can look at the data and look at the trends and look at your portal on the screen and see the dry down and be able to correlate that with outside air temperature and normal weather, and be able to pinpoint that a lot more accurately than stick your finger up in the air and your shovel in the mud type of method that we've, as rice farmers, have used for the past 100 years.
Excellent, thank you. I think we're getting close to we're coming up close to the end. I think we've got time for basically one more question before we wrap up. And I want to jump ahead. Real quick, and kind of looking down the future, into the future, if you will. What are the things that you see, or what are the events that you think would trigger or cause adoption to move forward faster? What are the major trends? I think we may have talked about these a little bit, but how do you see this type of technology evolving, and what are the critical trigger points that you see that would cause agriculture as an industry to accelerate the adoption of the technology?
I could bring up one real quick. In California, we faced new labor laws related to overtime and ag labor, and the labor savings alone with the automation of using your portal to irrigate is huge.
I'd like to add on to that too. I believe we're going to be going from 10 to 8 hours, in addition to 50% increase in labor over the next 4 years. Again, if we can, with water or with having real-time data and the ability to remotely control valves, I can therefore reduce the amount of irrigators I have, and then have the foreman dispatch those irrigators to where they're needed, fixing leaks where they are, and then overall, again, scheduling them more efficiently, and watering only when we need to, etc. So,
Dr. Brar, do you see the work that you're doing coalescing or causing growers to both adopt new cropping methodologies as well as adopt technology, or do you see those as separate threads? Dr. Brar, did we lose you?
Hello. Hi. Sorry, I had muted. Sorry. Okay. Yeah. So I can say that the irrigation is more and more becoming the high stakes game, and increasingly we are seeing that the dividing line between under irrigating and over irrigating is becoming more and more thin. So informed decisions, data that we have in terms of soil moisture status, and then its better linkages with the crop plant-based water status technology, and overall, in tying into that the overall canopy volume and different orchard systems. So as we get more data and more information, we will need to adopt different irrigation practices. So these technologies will come in handy when it comes to that. So yes, so I think there will be more and more adoption as we feel the more need for newer systems and newer irrigation practices.
Thank you, Dr. Brar. Dennis, I'll give you the last word before I wrap up.
Well, I think I think that most of the things that are going to trigger adoption have already been stated. But typically it's going to be a combination of cost crisis, regulation, desire for efficiency, along with the fact that I think if you look around the grower base that you've been dealing with, there are growers, I think, by their very nature, like to try things, are committed to improving the operations on their own farm. But typically trigger points derive from some sort of necessity that you have to respond. And and again, I think the Sustainable Groundwater Management Act would be a perfect example that once you have no choice, let the games begin. And then I think So regulation, necessity, and just the desire to continually improve tend to be the combinations that cause things to start moving. And I think the important comment is the trigger points are now occurring. They're not somewhere out there. I happened to come across an article on automation for lettuce harvesters in the early 2000s, and here we are at 2018. The labor situation was much different then. Now it's changed. Now there's activity, and so I think the bottom line is we've kind of got the perfect storm of the trigger points are well underway, and that is what causes industry to move on a more wholesale basis, and I think that's happening.
Yeah,
and let's not forget too, we've talked about regulation, but there's also a drive in demand that you have a more educated consumer that is in a more information prevalent environment, and there's marketability with being able to quantify a lot of these cultural practices that we're doing.
Absolutely.
Yeah, I think that's a great point. We should view this all fundamentally at the end of the day as also a great opportunity.
Perfect. Well, thank you all very much for joining the panel today. Really appreciate the input. I think that you guys have provided some wonderful insight. I know there is a bunch of questions. I have a question from Vegetable Grower. There's some other questions. We want to address those, but we'll do those with you directly after the webinar. So please know that we will get with you. I also wanted to let you know that we've just launched an irrigation assessment where we will come out and spend some time with you to understand your operations and then try to quantify that. We'll try to take your specific situation and assess energy, water, labor, and yields, and try to understand the type of the potential impact that informed irrigation could make with your farm. And we would love if this is something that you would be interested in reaching out and working with WaterBit on. We would be happy to do that. And with that, I want to thank you for joining our webinar. I want to thank our panelists for supporting us and for the great information, and wish you all a wonderful rest of your Tuesday.
Thank you.
Thank you very much.
Bye.